The full wave location technology. The depths of the Earth are in a continual stress-strain state. Every kind of impact, whether natural or man-made, on the geological environment cause various processes in the strata that are accompanied by energy emission and wave processes that reach out to the ground surface. This microseismic emission can serve as geophysical data for assessing the stress state of the Earth's crust, detecting the spatial position of its sources and the type of deformation that led to their formation. In 2011, in view of the high demand from oil and gas companies for monitoring processes occurring in the geological environment, Gradient focused its attention on the development and subsequent implementation of a new generation, innovative technology called the full wave location method. The full wave location technology aims to locate microseismic events and uses the full waveform signal data registered on the three components. It allows to locate the geological event and identify its type at the lowest signal-to-noise ratio. By locating the events and detecting the deformation type, we can solve a wide range of geological and technological problems for oil and gas companies. The technology can address such tasks as active natural fractures network mapping, hydraulic fracture monitoring, monitoring of various processes during hydrocarbon deposits development, including in situ combustion, water or steam injection into the reservoir, the production well drainage area, and others. The wave processes recorded during microseismic monitoring, due to reflections and attenuation in a heterogeneous geological environment, reach the surface in the form of a complex, low amplitude and predominantly low frequency response. To record weak seismic oscillations, highly sensitive, low-frequency three-component hardware complexes are used. They consist of a low-noise seismometer and a recorder. The autonomous hardware complexes are placed evenly over the survey area with a radius corresponding to the depth of the object under study, subject to mandatory remoteness from local noise sources. Microseismic monitoring from the ground surface is a complex technical task. In addition to the subsurface event sources, there are also sources on the surface, such as oil and gas infrastructure, moving vehicles, the atmospheric phenomena that act as interferences, and their intensity may exceed the level of the recorded useful signal from underground. In full wave location technology, the maximum likelihood method is used, which is theoretically the most noise-resistant method to identify the parameters of the weak signal. To use it, we need to know the full waveform of the signal. In order to calculate the full waveform signals by three components at the surface, the full waveform 3D numerical simulation is used. For each point of the volume of interest, the numerical simulation is performed.
Основная задача полноволнового численного моделирования
The main aim of numerical modeling is to get full waveform responses in observation points. A 3D seismic model is built on the base of compression and shear wave velocities of the survey area.
Размеры изучаемой области выбираются исходя предполагаемой трещиноватости ГРП.
Then the volume of interest is divided on a regular grid. The 6 pairs of forces corresponding to the 6 components of the tensor are applied to each node, and numerical simulation is performed. The simulation and event location are performed using a 35.6 teraflops supercomputer built on the basis of graphics processing units. The GPU computing cluster used in this process was ranked among the top 50 supercomputers of the Commonwealth of Independent States and was number 1 in Russia and CIS in terms of specific performance per node. To account for the environment model inaccuracies, Gradient's full wave location technology just like almost all microseismic technologies, involves calibration of the location system, which helps improve the accuracy of the results submitted to the customer. The location system is calibrated by impulse action performed at the depth of the target horizon, for example, from perforation or the burst of a detonating cord torpedo. This allows us to take into account the missing data on the velocities and attenuation during the location, especially in the upper part of the section. In the course of calibration, the model responses are transformed into the form of real responses of the calibration pulses on the sensors, and only after this conversion they are used for further location. Event location is performed at any given time by continuously searching for calibrated model responses in a real filtered field signal. In case of good overlapping of signals, the event is detected and located, and the seismic moment tensor is identified. The assessment of the seismic moment tensor provides a possibility to identify the type of deformation, an isotropic deformation, a double couple, a tensile crack, and others. The effectiveness of the use of the full wave location technology developed by Gradient CJSC has been proven over the course of performing various monitoring tasks at the sites of leading oil and gas companies, all of which are supported by positive feedback from customers. Gradient sees the scientific validity and transparency of the developed and implemented technologies as one of their key priorities.